Hello, I'm Susan Nash, AAPG. Really happy to welcome you to week number 13. And this is our pivoting new revenue and diversification strategies focus. Today, we're going to focus on tools and analytics and secrets to success. We are fortunate to have a really interesting group of innovators today. And I'll go ahead and introduce them, and then I'll ask each one to say a little bit about himself. So we have Peter Flanagan of Ubiterra, and he's going to talk about the impact of AI and ML on the pandemic and post-pandemic world, and just basically implications on technology and technology development. Peter this is his fourth startup, so he can share a lot about how to overcome some challenges. And we have Patrick Ng, and I'm going to stop sharing so we can see everybody. So we have Patrick Ng, and he will be talking to us about a new technology that integrates in a number of different fields, and it's an AI-based tool that helps cross disciplines into ESG. And we also have Cory Fehr, Integrity Insitu. We'll talk about basically in situ rock strength data, a lot of geomechanics there. And unfortunately, Deepak Atyam was not able to make it tonight. At the last minute, he got caught up in having to do a lot of prototyping. So I think that's a good thing, right? Anyway, and so finally, I want to introduce Larry Davis, our faithful friend and guide. He is a professor of economics at Texas A&M Texarkana. So Larry, would you like to say a few things?
Just like to say welcome. I'm happy to be here. Looking forward to the presentations tonight. They're always exciting and enlightening. So let's move forward.
Great. So let's start with you, Peter. Would you like to say just a few words about yourself?
Yes, thank you, Susan. So, well, I appreciate the opportunity to participate in this webinar. And I'm a geophysicist by training. Started my career at Amoco, now part of British Petroleum. And then early on in my career, sort of got the entrepreneurial bug and had a high level of interest in software. So as you touched on, I've been doing this now for many years, involved in building GG&E software, both in the workstation environment and now in the cloud, and also some financial software for the oil industry, something called OilDex, which is used by a lot of oil companies. And and we're involved in a new venture, a new product called ZoneView. I'll touch on it very, very briefly in my presentation. My presentation is mainly big ideas. So.
Excellent, great. Well, welcome, Peter. So Patrick, would you like to introduce yourself and tell us a little bit about yourself?
Yes, this is Patrick Ng at Core Energy. I started in research geophysics at Western Geophysical. But one of the common things that I've done over a number of years is to help customers see hidden dimensions. So the early days, people drill on 3D structure, and we introduced AVO to the marketplace. We de-risked these projects. And then later, Deepwater Gulf Mexico, conventional imaging, couldn't see any of these big reservoirs subsalt. So we introduced depth imaging to help customers find the biggest 3 discoveries in the Gulf of Mexico. So fast forward to today, I work in a very small boutique shop that 3 people, we acquire mature assets, operate and exit. But right now, the truth is that business model is broken. So when I heard about the pivot about a month ago, there were some ideas. So I just like to come back and share with you all.
Oh, that's great. This is what it's all about. Really appreciate it. Take some courage too. So, and Cory, would you like to introduce yourself?
Certainly. Thanks very much for the platform, Susan. I appreciate the invitation. My name is Cory Fehr. I'm the president and CEO of Integrity Insitu. I founded the company 7 years ago here in Calgary, Alberta. We've since expanded into Houston. And what we're all about is geomechanical testing in situ, real-time data, with a downhole tool that I invented and had some people much more intelligent than I actually make reality. So we're now on the second version of that tool. and we'll be testing it in Saudi Arabia this winter, hopefully.
Oh, wow. That's a big breakthrough. So, question, are you originally a geophysicist?
No, by trade, I was actually a software developer, and that was back
Okay.
in the 90s. But before I was a software developer, I built boxes at Core Labs. I literally took cardboard boxes and I folded the tabs and I wrote the name of the weld on the box. And then eventually I was promoted to slab the core that went in the box. And then eventually I was promoted to test the core that went in the box that I had built. And then eventually I was running that lab. And then I went back to school for computer programming. And after a few years of the software world, that was in the late 90s, early 2000s, the dot-com bubble burst. And as a junior, you're not getting paid much. So you get more and more duties piled on because you're still not getting paid much. And that led to an opportunity in the patch. And it's been, I'm starting my 22nd year in the patch here this fall, largely on the operations and project management side. And yeah, after the after the computer programming stage, I did go back to technical school for project management as well as reservoir engineering as well as geology.
Oh, that's very cool. And I'm glad you mentioned Core Lab. I started out, my first summer job while I was an undergraduate was at Amoco Research Center in the Core Lab, measuring porosity and permeability.
Right.
And
Yeah.
those were back in the days when people could smoke in the lab. We used to clean out, boil the cores over xylene that was just boiling. And there was a guy who smoked who'd lean over the boiling xylene. I don't know how we kept from having a horrible accident.
Yeah, we used to use toluene, and
Ooh.
I'm sure just as volatile. We handled a lot of mercury. I exploded a lot of rubber membranes doing porosity testing on those massive frames. Anyway, good time. Yeah.
That's funny. Yeah, we use mercury too. Anyway, so Larry Davis is a professor who focuses a lot on strategic planning. And I just thought maybe you could mention a few things about strategic planning, then we'll go to our first presenter.
Well, the issues of strategic planning, I'm teaching a graduate course now and having to wrestle with the students. They turned in their papers, about 20 pages. And anyway, I give them a good template. There's a system, and they want to approach it, rather scattered and not, follow through with the system. So a lot of people out in the professional area, I've had comments that, yeah, we have a strategic plan. We met for a couple of hours last Wednesday afternoon, and we came up with what our goals are for the year. First of all, most don't know what the goals are, the objectives, or the difference, and the separation of those and strategies. So it makes a difference in the success of an organization to be able to, cover all the bases and give an assessment of the external things that can zap you and surprise you, like a coronavirus, that people didn't anticipate. It affected a lot of businesses, but that's something out there that did come along. And there needs to be a good self-assessment of like HR, for example. I mean, do you have adequate employees? Are they trained? Do you have excessive turnover? And then doing that serious analysis, you can come forth and maybe detect some things that need to be repaired to make the system work. It's kind of like a football team. If you have a great quarterback, but you don't have anybody to receive the passes, it's not going to be successful. And if you don't have a center who can snap the ball accurately on a punt, you're not going to be able to be successful in that. So all the links tie together. And one of the things I observed, a lot of companies are very successful in doing what they need to do, but many others fail because they want to do shortcuts and don't understand the system. So I've enjoyed the presentations in this series, and it indicates a lot of people have been successful. And the thing that impresses me with the coronavirus and some things that are coming along to affect businesses, that some have been able to do a reassessment and redirect and consider what is necessary to move in a new direction to be successful. And then others out there have failed. I've seen, poor pitiful me, look what this has done to me. And there's just different outlooks and different approaches, and a good strategic plan, a solid plan can not guarantee success, but maybe improve the odds of continuing success. So anyway, enough for me. Let's move forward and hear the experts tonight.
Well, thank you. That was excellent, though. I think it was perfect for this group too, because we'll be talking about exactly what you mentioned. So anyway, Peter, would you like to share your screen? And while he's sharing his screen, I'd like to thank our sponsor, Unique Ventures. They have a wonderful group of people who are helping startups and people who have in the commercialization phase, helping them get paid testing and in the field.
Who can share? All panelists.
Looks like you should be a co-host. You should be able to. Do you see your green share screen in the bottom?
Yes. Let's see. I'll try to push that button. There we go. And we'll see if PowerPoint is going to cooperate here. Okay, you should be seeing a slide that says paradigm shifts.
I think you need to select that. Hover over and select you'll see a number of squares to choose from. So just
Yeah, I chose one. Let's see. Come on. We use Teams. We use Microsoft Teams heavily in our. Okay, there's screen two. Oh, share. Okay, there we go.
Great, perfect. Oh, I know they're all a little bit different.
Yeah.
That works.
So okay, good.
And you can
We're
go
there.
ahead and hit the slideshow views, and it'll make it larger. Perfect.
Okay, I'm using a new PowerPoint template, so hopefully everybody sees this fancy animation.
It's beautiful.
So being a serial entrepreneur and having that view of the world for what it's worth. So here's my view on the pandemic and also on paradigm shifts hitting our industry and how we're reacting to them or what we're doing with them in our company. But trying to stick to some big ideas here overall. So I'm going to start with sort of the first big idea, which is why is the physical world intelligible to the human mind? Now, this is a concept. The deep philosophers have been talking about this for hundreds of years, thousands of years. How is it that we as human beings are able to be in this physical environment, and unlike any other animal, we're able to make sense of it, and we're able to reason about it. We're able to come up with mathematical laws about how it operates and be able to make predictions. And then from those predictions, do things to our environment that are usually and mostly beneficial to us as a species. And it's worth pointing out that I think geoscientists are particularly good at this. This is something that we as geoscientists really do for a living, looking for patterns in the physical world, whether it is, and using that to look for energy, look for minerals, predict the weather, whatever, all kinds of things. And maybe in a more general sense, use this ability we have as human beings to reinvent our environment to our own needs. So unlike the field of rabbits in Malthus's famous analysis, where you rise as a species to the carrying capacity of your environment, and then you sort of stop right there, dead in your tracks. We're not like Malthus's rabbits. Because of this special ability that human beings have. And then that to meet the challenges of our environment, which the human species has been meeting throughout its whole history. We've never not had challenges, but some of the challenges are easier to deal with and happen in a more stately, steady state kind of way, and other challenges come upon us in a more discontinuous and rapid fashion. So here's an example of continuous innovation. So continuous innovation is the application of the human mind to meeting the challenges of the environment in a stepwise, incremental fashion. And so I'm sure this is an audience that knows all about the Pleistocene megafauna, and the human species as we understand it. Modern human beings have been around roughly 300,000 years, at least anatomically, And the megafauna fed humanity for 95% of its history. So that was the hunter-gatherer phase. And human beings were so successful at it that our ancestors wiped out the megafauna. But in the process of hunting and following, large animals around during the Ice Age, basically, lots of things were invented, no doubt, right? There was a continuous evolution and improvement in spear tips and points, and all different methods were devised for capturing animals. An interesting one being the cliff fall, where they would cause a herd of large mammals to go over the side of a cliff and then go harvest them. But this went on for a long, long time, and fed us for thousands and thousands of years as a species. So then, now an example of discontinuous change and therefore discontinuous innovation. So finally, the megafauna are depleted; they're hunted out, and many megafauna species have gone extinct as the result of human predation. And this coincides with the end of the Ice Age around 12,000 years ago, which leads to drastic changes in the climate, sea level rise of what was it, 120 meters or something? Sea level goes up, wiping out of coastal villages. So this was a big, big event in the history of humanity, and it led to a paradigm shift. And a paradigm shift, I would define as a technological response to a discontinuous change in our environment. And so farming emerges. And that was a drastic technological advance or shift for us as a species. And like any paradigm shift, it created opportunities for other things to arise or to evolve or to come into existence that were unimaginable or never could have existed previously. And so it leads to the rise of, or the invention of towns and cities and population centers, and people centralizing into groups, to cooperate in order to farm, in a scalable way, and trading starts on a larger scale and that kind of thing. So this was a very, very important example of discontinuous innovation in our history. Now, or paradigm shift, as it were. So now an interesting question is, how does a paradigm shift happen? What are the catalysts? What are the keys for this to happen? And one of the truisms is that established organizations struggle with paradigm shifts. So this is why we have, for example, a startup culture in this country. So, large organizations are good at continuous change and continuous innovation and incremental refinement and developing markets and servicing large customer bases and growing gradually and incrementally. But discontinuous change, dealing with a paradigm shift, a quantum change, generally happens through individual contribution. So there's some person somewhere who has applied his or her mind to the problem at hand and come up with an invention, basically. And in fact, if you're of that type of person, which I guess I am because I've been doing this for 20 plus years, you actually broker in paradigm shifts. That's what you do for a living. You're always on the lookout for opportunities arising from small, medium, or large paradigm shifts that are underway. And there's all kinds of examples of this in the history of business and even in current events. The name Elon Musk jumps to mind, right? Like with Tesla and the Model T Ford, the mass production line. There's all kinds of examples of this that people study and know about. But that's been sort of, in essence, what I've been doing in my career, looking for paradigm shifts and applying software, to find better ways to do things in our industry. So, but when you talk about dealing with a paradigm shift and trying to innovate something, trying to invent something, that inevitably, more often than not, leads to the topic of pivoting, or the concept of pivoting. So pivoting is a way through a paradigm shift. It's a way to, and it's something that we as entrepreneurs are all too familiar with, right? And you know, it's sort of a truism that any startup, technology-focused startup, the original business plan isn't the business plan that ends up succeeding for the company. You have to go through various permutations and try a little of this, try a little of that, and until you find something that clicks. And if it doesn't, you don't make it. And so pivoting, you know, to use a concept out of, say, geophysics or mathematics, it's sort of like it's searching a solution space. So you're, rather than just trying to incrementally improve, you're finding a radical new way you're looking for a radical new way to do something. And so you're sort of jumping around. You're observing, analyzing, predicting, applying that innate human ability to do that. And then you're trying things out, and you're revising your business plan, and then at some point, if things work out, it works out. And quite often, fate or chance plays into it, or serendipity, right? Being at the right place at the right time, or maybe you're a little ahead of your time, but then your idea, something changes, you know, and as you move through this paradigm shift, and it'll work out. So let's apply this thought to the pandemic. So the pandemic is an example of discontinuous change in our environment. So out of the blue comes this, you know, this virus, you know, and spreads rapidly, and causes this drastic this crisis and change that demands a response. And so me, as being an entrepreneur, being of that mindset, you know, it's not at all surprising to me that a single individual pops up. So I don't know how many people have heard of Sarah Gilbert at the Jenner Institute in England, but she has invented, and the Jenner Institute, now in partnership with some much larger organizations and pharmaceutical companies, has what appears to be the most promising vaccine that is, I think, entering phase 3 trials. But it's an example of kind of what we're talking about here, of pivoting, because she, some years ago, worked really hard on, you know, the MERS, which I can't even say what it stands for, but a virus that appeared, I think maybe in Africa, and or maybe the Middle East, I forget. But it was a technological success, but not a commercial success. The approach that she came up with at the Jenner Institute to deal with the MERS virus. But when COVID hit and came out, you know, in January, and they got the genetic sequence, she had this insight that she could take her research on the MERS virus and the vaccine she had developed there and rejigger it a bit, and come up with a vaccine for COVID. And that's and then once that became apparent that it was looking successful, capital piled on. I believe the Bill and Melinda Gates Foundation donated, and the British government, and so on and so forth. And it looks like it's the lead candidate. We might have a vaccine by the end of the year, or hopefully sooner. And once again, thanks to her, and thanks to all the people supporting her, human beings are going to reinvent their environment once again to suit human needs, you know. And so what kind of opportunities does that lead to? Well, there's a really interesting article in the current Harvard Business Review. I meant to put the link in here, but if you just look up Harvard Business Review, it'll take you to the current issue. And they have 6 or 7 articles on the change in work, you know, being catalyzed by the COVID crisis. And one of the key points that comes out is that all of a sudden we're in a situation, thanks to the internet, you were able to work from home previously, but it was the exception rather than the rule. The organization's heart was still in that office, right? Or in their office. But now they point out in the article, at least for the last 3 months, working in the office is now the exception rather than the rule. Working from home is the rule. And it's causing all kinds of reevaluation by all kinds of organizations. So Microsoft did this studying, I don't know, 30,000 of their own employees working from home. And there's a really interesting article in there that, but it's interesting because you can compare this a little bit to the rise of cities with the rise of the invention of agriculture, of farming. And cities were basically an invention, to allow people to congregate together to deal, in order to have that level of cooperation and that economy of scale to be able to farm, to make farming economically feasible. And then the Industrial Revolution sort of doubled down on the need for cities, to have workers congregating to work together in factories. But now, at least for those in an information centered situation or work, and with the internet, and now with this paradigm shift we're going through, do we really need cities? And so there's an explosion of price in real estate surrounding metro areas, including, I live here in Denver, Colorado. Mountain real estate is going crazy. In New York, where I'm from originally, land and houses in the outer, more desirable suburbs, and even in rural areas, 150 miles away, like the Catskill Mountains, is just going crazy in the real estate market, because the realization that, hey, I'm an information worker working on Wall Street, and I don't really actually need to be in my office and have an hour commute each way every day and deal with I could have a better quality of life. I could just, and so this is a great example of an opportunity coming out of the current crisis and I think it's going to be transformational to all of our companies and all of our situations. And so I think this is my last slide. So what about our industry? Well, we were already going through a couple paradigm shifts. And if you look at number 2 there, the transition from, at least in North America, from conventional to resource plays is a great example of a paradigm shift. And we're all actually still working through that. And it's having big impacts on the professional societies like the AAPG and the SEG and so on and so forth. It's causing it already has caused the reorganization of workflows in many oil and gas companies, and how they organize asset teams. And meanwhile, when you play in the software space like we do and produce software solutions, software is going through just as big a paradigm shift as the oil and gas industry. The shift from PC workstation-based software to cloud browser-based software, and that one's just getting started. On the consumer side, we're all pretty far along in that shift. But in the software we use in our professional work, GG&E software systems and so on and so forth, we've barely gotten started. And then superimposed on these 2 paradigm shifts is, of course, the third paradigm shift caused by the pandemic, that we've just talked about, the paradigm shift from office-based work to remote work. And there was already a bit of that going on in our industry because, there was already a trend toward, trying to remote control our drilling rigs. And that's a trend that is moving rapidly, so that, the future might be, completely automated rigs with, just a skeleton crew, just keeping an eye on them, and, heavy automation. And so, and anyway, so here we are. We started out really with paradigm shift number 1. We just started as a company that said, oh, well, the cloud's great. It's a great paradigm shift. Let's use that to help the oil industry store seismic data and well data in the cloud, help them leverage and exploit, Amazon and Microsoft storage and that kind of thing. Then we quickly ran into, wait a minute, there's this other paradigm shift going on, into resource plays, and all the workflows are shifting toward real time and toward, the geoscientists are suddenly really important while the well's drilling, not just up to the spud, but actually up to during the whole drilling process. They're running to the geoscientists, asking them how to, where the drill bit should go. And so we pivoted to adding that capability to our system. And then now, it being a cloud and browser-based system, it was great for distributed remote workflows, out of the box. But nobody did, that wasn't the primary emphasis. But then suddenly in the spring, the COVID thing starts, and now there's a great example of serendipity playing into pivoting, because suddenly we're at the right place at the right time with the right product, maybe. and we are getting a lot of interest on that basis. And so, and that product is called ZoneView. But anyway, that is, so I guess in conclusion, I would say, as an entrepreneur and as somebody who's an optimist about our ability as human beings to develop technology to deal with whatever challenges the environment lays down on us, I obviously I don't want to get COVID myself. I haven't, but I'm very, very confident that, we're going to sail through this. Maybe Sarah Gilbert's vaccine is going to work. I bet it will. But if hers doesn't, somebody else's will. And this time next year, none of us are going to be, mandated to be sitting in our home offices doing what we're doing. But I have a feeling a lot of us still will be sitting in our home offices, because that's going to be a benefit and a new way of thinking about work that's going to come out of all of this. So that is my talk.
Oh, thank you, Peter. That's really interesting. You bring up a lot of good points, and I really like the focus on the inflection points, the paradigm shifts being the opportunity, and how you find that, the specificity. That's great. Well, Patrick, would you like to share your screen? Patrick Ng is next.
Yes, I would love to do that. Let me
Great.
see. I click on the green thing, I suppose.
Let's see. Oh, I didn't hit unshare. Oh well. I'll mute it.
So now you can see it.
Yes, perfect.
Okay, so I said that our business model, acquire, operate, and exit mature asset, kind of broken right now. So June 17th, I think that was a pivotal moment of the webinar. I think it was a ESG theme, and I think the takeaway for me is three things. One was that investors perhaps are going to adopt ESG scorecard, meaning beyond a financial performance metric. And I think Mr. John Hofmeister, he was a CEO at Shell before retired. I thought he made a comment that at some point, investors are going to reward those companies, operators with good governance on ESG, and translates into lower cost of capital. Well, what really spikes my interest is that the BlackRock, the largest ETF and fund management group in the world, have $1.3 trillion of firepower putting into ESG, whatever that is. And you can see that's growing. Now, all this is great, but to me, I start looking into a little bit more, and then I realize there might be two aspects that what we do is applicable. Okay, let's put things in perspective. We are so good extracting stuff from the ground. We take stuff out. But there are two aspects of environment, sustainability, and governance. One is that, let's say, carbon capture and storage. The other is energy storage system. Both of these are about putting things into the ground, not taking them out. And in fact, some of these had to do with perhaps if you have a depleted asset, maybe opportunity to use it, repurpose it to store carbon capture. Okay, that's interesting. But the one that's really, I think, energized my thinking is that the energy storage system. If I understand, it's the physics is, well, it's been around since 280 BC. The Greek did the water wheel. It's really about converting potential energy into kinetic energy and back. You know, those Roman viaduct, you remember? The water at the top of the hill in the cities where the baths are down there, the water come down, they turn the water wheel and carry it back up. But in this case, whether it's solar or wind, let's say at night, the sun is not shining or the wind stops blowing, but during the day, they would take the water, pressurize it, and push it down through a well into some storage. In this case, possibly reservoir of depleted. Well, I guess shale is non-porous. So if you can just put the water, pressurize it there, at night, you can release the valve, the pressurized water come right back and turn the turbine to generate electricity. So that's one way of thinking about, wow, maybe there's a element. I think something common whether we're drilling for oil and gas or this kind of energy storage, is finding the right area with the right combination of factors. So it becomes more like a real estate business, location. In terms of water, just make a point. I think if you talk about on a nominal, 1,000 home, 10 hours electricity, you need about 5 Olympic-sized swimming pools of water to do this. So I checked, and I think depends on the configuration of fracking a well, could use anywhere from 5 to 20 Olympic pools of water. So it just tells me, hey, some of these are shale wells. Once we have produced, depleted, there's plenty of storage capacity to do this kind of energy storage. All right, so next thing is, well, interesting, but where are these wells? Well, here's a little, just a high level map view. They're about little over 200,000 of shale wells drilled since 2010. So next, let's go shale spotting. So I'm going to switch off for this and go to, okay, you see my screen here as well?
Yes.
Okay, so let's say I had this little circle. So I'm going to move it around to go to places where I pick up where wells are. So let's say, for example, I know in Permian or desert is right here. And let's say I'm just thinking, oh, are there some wells over there? And there are. And in fact, I can zoom into a little bit closer. So you remember if you fly into the airport near Midland or desert, you see a lot of these wells nearby. But not only I can see, now each one of these red dots is just a well. Now right now, in the back, I have a lot of information about the well and so forth, but in this particular, just simple application, simply just see where these wells are. But in terms of, one more thing I can do since I'm here, I can actually go and look at. So some of these wells are not too far from where people live. So that's one. Now, on the other hand, if I go up to Williston, the town, Batkin, I can see, hey, some of these are near, maybe interesting. I can also do that. And maybe I can turn on and just see what, oh, look like somebody's house. Now this is a Google Street View. So we just verify I end up following. So the interesting aspect for me is that if I can start interrogating some of these wells and figure out, hey, which wells are depleted and they're close to some towns or places where, hey, maybe a transition to a renewable could use or benefit from hooking this up as an energy storage system. So this is my first thought. Now, obviously, there's a lot more work that could be done. This one is like Pittsburgh. And I think Washington County is one of the most prolific area. And again, I want to just curious, if we go shale well spotting, just want to see, hey, you know, it's totally different than West Texas. So let's see what we find out. Now that's a kind of pretty area. So we're just looking at some static picture, but just one of the possibilities is that if this is just a front end, it hook up to some drone data people would use to be able to survey an area, facility, and look at, hey, how close is proximity to the road or any of the infrastructure. So this could be easily fitting. So in what I show here simply is just to say, is there a connection of what we do in oil and gas to something beyond what we currently do? But the important thing is behind, just by looking at from a geo-search front end, the two things, let's say we have used machine learning in many of the things we do, whether here it could be decline curve analysis or in terms of ranking drillable locations. So one of the things is the granularity of the well production data. So here, let's say, for example, I got, little over 200,000 wells with production history. But use that, I can derive a optimal allocation. Now, I'm not saying I do that, but I can help to deploy capital to do what I guess a lot of people talk about asset allocation. And so this is one of the applications. Using granularity of data, I can get a better feel of the risk and return profile. But just take that and move it from oil and gas to making prudent investment decision to energy transition. Well, this granular well location, perhaps for looking at potential sites for energy storage system. It's scalable, it applies to a lot of places. The GeoSearch really is trying to determine what's the area of mutual interest. It's not just from oil and gas perspective, from other stakeholders. For example, if you're a landowner, you might want to say, hey, all the wells that produce peter out, but what other opportunity can I turn my land into? The mineral rights, you still own it, but you can choose to work with other parties. So most important of all, the same optimal allocation strategy can include renewable. So that as any operator can start looking at how do I make a transition portfolio that also manage the risk. So what does that all mean? Here's an example. What we do is that using market risk portfolio theory, which just really quantifies the value of diversification, simply as either a reduction in risk or maybe a boost in return. So I substitute, instead of stock and bond prices into this market risk portfolio model, I can use the granular well production data as for my assets. So instead of financial asset, I'm talking about producing assets. So let's say, for example, I have 4 of these guys: Eagle Ford, Williston, which is Bakken, and DJ Niobrara in Denver Basin, and then Marcellus, which is natural gas. So I can ask the question, hey, if I'm one minimum volatility, I just want to sleep like a baby, I don't want to worry too much. So given that, there's an allocation in the top row. But if I'm a little bit more risk taking, I want to have the opportunity to maximize my risk adjusted return. That's typically use the Sharpe ratio, which is really about expected return divided by the volatility. So in this particular case, given the commodity price outlook, I think natural gas is a good bet. So Marcellus ranked very good in terms of good weighting. But the one that's most interesting, and I think it varies a lot with what our assumption in terms of future price of the commodity prices, is the risk parity criteria. That means for given, this is not equal weight, equal exposure to risk among all 4 assets. So what does it all mean? So the next picture, let me use that. So for detail, I recommend just go and check out this paper published back in 2017. And the idea is that when I have the 4 assets, I can construct a so-called efficient frontier like this right here. And the minimum volatility typically is the one over here with the minimum volatility and certain return. The maximum Sharpe ratios typically end up here before this thing kind of flatten out. But anywhere in between is where if I say I'm willing to take volatility risk around 40%, so what would be the optimal allocation of the asset, of the 4 assets? And I can figure out here. But if I'm willing to accept a little more risk, I move over here. Also, it's a different weighting. So that's kind of risk parity, give us that flexibility. But if I do equal weight, sometimes it might be close, but it's not always close to the efficient frontier. So that means there's pretty much room for improvement. But that's the detail. But what I think I want to relate back to about scorecard is that if given the particular, at the time, what the Federal Reserve fund rate is, the best rate for the banks, I can take a straight line from that, let's say 2%, and draw it all the way out. So anywhere that I get a tangent to that efficient frontier, that's the best allocation I can get for the portfolio among these 4 assets. And if I can do that, then I would achieve a better, or maybe the lowest weighted average cost of capital, with the proper structure, debt versus stock. But relate to, I think Mr. John Hofmeister talked about the scorecard or the cost of capital. This could be a very straightforward measure to financial resilience. If we improve, let's say I include a renewable in this particular portfolio. So instead of 4 assets, I may have a 5th asset, which is renewable. It might be a solar, it might be wind, but combined perhaps with an energy storage system. So that's kind of where I see this potential of taking what we do and do well in oil and gas domain and incorporate additional data and be able to make a paradigm shift or pivot to include ESG in that whole scenario or portfolio. And we can quantify it. So let's say, what's the future of oil and gas? I love this picture from Colorado School of Mines. It's a mix. It's not oil and gas. It's not just renewable, but it's not binary. Okay, so we're going through transition. In fact, I think earlier this week, it was SPE Live. There was a live hour discussion with very passionate speakers, talk about engineers, stakeholders, and other. But one of the things that even come out is that if companies do not consider the transition in 5 to 10 years, the statement is that they might be left on their own and the world is moving on, or the investable dollars have moved on. So what makes it today? We can start with the geo-search engine. So that, to me, perhaps is a fast bridge from oil and gas domain into the ESG universe. But for me, it's not about just oil and gas, but also a scalable platform for geoscientists, engineers, and ESG investors to come together. Meeting of minds, and I think a lot of what the previous speaker talked about, paradigm shift and continuous innovation. Hey, one of the things I learned many years in the industry, if I can get a customer look at a map and tell me his idea, or seismic, interpreter, look at a section, and start pointing out what was exciting and all that, you learn a lot. But also because different people with different background look at the same problem, you have the opportunity to create some real breakthrough. So just looking at this, Oklahoma City, nearby, a bunch of these shale wells, old shale wells. And if, well, Susan, you live up there, if we can turn around and say, hey, we can add a little ESG in there, Oklahoma City score really high, and maybe that would make it exciting. Well, thank you all, from the heart of Texas, and taking the time in your company. I appreciate any feedback and comments. I'm open to it.
Oh, that's great. Well, I've noticed that we had a few questions, but what we'll do is hold all the questions till the end. So make sure that we get through the program. So thank you, that was great. Cory, would you like to share your screen?
Sure.
Really interesting too how these things dovetail and that the presentations are complementary.
Can everybody see my screen?
Mm-hmm.
Yes.
A lot of blue there.
Looks great.
Thank you. Okay, so this is all about the Integrity Insitu technology and real-time geomechanics testing. I'm going to go through the 5 W's essentially. Who, what, where, when, why. This is the who. There's a slide missing that I can't quite figure out how to work into this again. I used to have it slide of my family, and that's always part of the story and very important background. But these are the folks that make all this happen here at Integrity Insitu. We've got roughly 150, 160 years of R&D and engineering design experience on the team here. We've got a number of geomechanical experts, various Ph.Ds from all over the world that we consult with as well. But we do have our own in-house expertise on the geomechanics side. And I'm the crazy one that came up with the concept back in 23, it was probably 2011, 2012 that I first came up with it, but 2013 is when I quit my job to start the company. It is the fourth business I've been involved with and the first of the R&D nature. So this is the Integrity Insitu team. Now, why do we exist? Everybody needs to be solving a problem. And if you're not, you don't have a business. The reason we exist is that when I was working on the operator side, most recently, I was at an oil sands company. And if you're not familiar with oil sands, there's really two types of projects. You've got in situ projects where you're too deep to economically mine down to the resource, or you've got a surface mine, which is similar to any other surface mining project where you've got big electric shovels digging away all the overburden and removing that material. And then once you reveal the ore, everything gets scooped up and processed. If you're dealing with an in situ play that you can't mine with conventional means, you'll drill some horizontal wells into that reservoir and you'll inject steam into the top well and you'll produce that mobilized bitumen out of the bottom well. If you're going to do that, you need to make sure that the layer of rock above that steam chamber is competent and that you don't exceed the fracture pressure and that you understand the geomechanical properties and the continuity of the resource of that particular boundary to make sure that that steam chamber stays in place for a number of reasons, but very much so on the HSE side of things. And back in 2006, there was a massive steam release in the forest of northern Alberta that left a crater in the ground, literally the size of a soccer stadium. So we don't want that happening again. The government stepped in and put a bunch of rules in place, and geomechanics became much more commonplace in the oil sands industry here in Alberta right around that time. So needing to figure out the strength of that layer, and this is a problem that's is not unique to oil sands, but anytime you want to understand the geomechanical properties of that rock and the stress conditions of that particular area, you'll be doing some mini frac testing, probably might run some specialty logging tools and then try to correlate that with some core data. And then if you can capture core, you'll run it through a lab. And, you know, these are full-size cores, 3.5-inch diameter. And you could be waiting months, 6, 9, 12 months to get your data. Expensive process. At the end of the day, the information you come up with is based on disturbed core. It's all well and good. There's a lot of brilliant people doing that work, and that's what's been happening to date. But in my experience as an operator, it was a very unsatisfactory process due to a lot of different things, but one of the main issues was core recovery and spending $1 million to see 2 core samples in a report after 7 months of waiting. So those types of frustrations and those different inherent problems, and at the end of the day, knowing that those numbers are based on a disturbed core sample, those are what led me to start this company. So our solution was to perform those physical tests in situ, see the data in real time, and perform physical mechanical tests directly to the wellbore wall to obtain those rock properties. So this is what we did. Designed this tool, built it, started testing it in 2016 in northern Alberta. We ran this tool around 5 times. We ran some of our own test wells, and we also tested with a couple of clients. It did its job well enough. The concepts were sound and everything was proven out well enough on the bench in particular. But on the operational side, there were a lot of challenges with dealing with a rig and how do you deploy this thing without damaging components and whatnot. So the market really fell apart in Canada for the shallow oil sands market here really about 5 years ago. So even though we had this technology and we were moving down the path of proving it and commercializing it, the market just wasn't there. So we needed to pivot, and this is a while back now. And we did so, moved into the deep market, and we're now designing the next version of that tool so that we can work in much higher pressure and higher temperature wells. What you see here, I'll make my pointer, whoops, a laser. What you see here, this is a prototype, and this tool, it's got multiple functionalities to perform these tests, physical and mechanical tests on the wellbore wall. But this thing is only rated for 3,500 feet. It can't work in high temperatures. It can't work in high pressures. That's because it's a prototype. Now, when you're a startup company and you're developing downhole tools, I don't have Schlumberger backing me. I don't have Weatherford or Halliburton. Weatherford's a bad example, obviously. Halliburton, Baker Hughes. So we had to walk before we ran, and that tool had some pretty serious operational limits. But we did prove the concept to ourselves well enough that we're now building the next version with the support of Saudi Aramco. So what the technology does, what it's all about, are these three main functionalities. This is the bottom of the tool. This thing here is called a shear head. This is the middle section of the tool. This thing is called an intelligent packer. This is the top section. Those are dumb packers versus the intelligent packer. And what we do is we run a mini frac or a defit. These packers isolate the zone of interest. Water is injected from surface through the drill pipe. We run on drill pipe for a couple of reasons, and out these injection ports. So three functionalities: shear head, which replicates a shear box test as well as a scratch test. And I'll get into that. We've got a compass on board the tool so we can orient the data as well. The intelligent packer, which is exactly that. It's an instrumented packer. There's arms inside of that device, and those arms follow the membrane that we expand when we activate that section of the tool. What we do is we load the wellbore wall with force, and then we unload the wall, and then we load it again in a higher force stage. And we run that cycle multiple times, and we watch how that rock responds to getting pushed around. In the tool, we're measuring force and displacement. In the rock, force translates to stress, and displacement translates to strain. So through that process, we're measuring Young's modulus. You can easily arrive at Poisson's ratio, and we can also, this also provides shear modulus. So that's just part of what's going on with the intelligent packer. And then the mini frac, or defit, as people like to call it, I call it a mini frac, is a very low volume frac job. You want to fracture the rock, make sure you have a fracture in place because you just watched it. Allow the fracture to close, and then see how much pressure does it take to reactivate that fracture, which is your fracture closure pressure or minimum in situ stress. Now, we talked about that shallow market going the way of the dodo and us needing to get away from that world. So we did, and this is the new version. Obviously, these are a couple of very generic drawings of components in that version, but this is what we're building right now, and we're bench testing it right now. The hydraulic power unit has been bench tested for the past about 2 months downstairs in our shop here, and we have successfully tested our hydraulic drive power unit to 20,000 PSI most recently over the past week. So we call this the Insitu tool, which stands for Insitu Geomechanics Testing. And it is the same functionality as what we just looked at, but it's in a very different package. It's designed by our own internal team, by a group of not necessarily geomechanical minded folks, but mechanical engineers and some very specific downhole tool experts, so that we have all of that tribal knowledge kept in-house, whereas in the past it was all done with consultants. Bad idea. So the shear head, what we're doing, like I said, we're replicating a scratch test. There you see a traditional scratch test, and we're replicating a shear box test. These marks, these scratches, represent what's happening physically to the wellbore wall when we run this tool. We see low stress, applying low force, medium stress, and high stress. I'm going to go back a couple slides. On the bottom of the shear head, you see these circles. Each one of those, there's 9 of them on the shallow tool, and there'll be at least 6 on the deep tool. Each one of those circles is a hydraulic ram. And I see there's a bunch of stuff on the chat, but I'm not going to read it at the moment because I'll get distracted and lose my place. But each one of those rams has a cone on the end of it. We know the geometry of the cone. We measure the displacement of every single hydraulic ram independently and to within 1,000th of an inch. So we're measuring those displacements and movements very, very, very precisely. When we penetrate the rock, we tell the tool, okay, penetrate to this depth, go. And then once we've applied that normal force in our first pressure cycle. We then apply shear force, and we move a ram in a different part of the tool perpendicular to that normal direction. So now we're applying force normally, and now we're applying force perpendicular to the normal direction, which is shear. Normal force, shear box test, exact same thing. Different process, exact same mechanism, exact same effect. We run it in higher and higher pressure cycles, like I said. Penetrate at this depth, it takes this amount of force to get to that depth. Penetrate to this depth, it takes X amount of force to get to that depth. So we can run as many cycles as we want. In this particular instance, this is from bench testing. This is a barrel of cement and sand that we scratched. And we scratched this thing hundreds of times. And we cored that barrel of cement and sand and ran a direct shear box test and correlated the data, and they matched. I'll get into a bit more of what that looks like. What you're looking at here, and this slide is got a perfect name. Building shear head theory from scratch. You just saw the scratch, but we are building it from scratch literally. This animation was built by the University of Cambridge. And if you look down on the bottom of the slide, you can see a lot of initials. Everybody loves PhDs. They're very brilliant, and I love working with them. David Yale is a very prominent figure. He was expert witness, geomechanical expert witness for ExxonMobil for 25 years. David Yale is who built the first 9 versions of this analysis protocol of how we handle this data. What is it doing? And then Mehrdad Soltanzadeh, a friend of ours who was in Calgary, he's one of our close consultants. He then evolved the protocol further, and Sheldon Wang also took a crack at it and made some changes. And this is the type of stuff. This is Greek to me for the most part. I obviously know enough to hang myself, and I've got a good handle on geomechanical concepts and principles, but I'm not a geomechanical expert, and I'm not a geomechanical engineer. So we recognize tangent, cosine, area, stress, but most of you will understand this a lot better than I will. But this animation shows you what is actually going on in the rock when that cone penetrates that surface. It's not simply the granules of material you're physically contacting at that surface interface that you're affecting. That pressure, that force is moving into the rock. So the University of Cambridge simply put this together to help us visualize that. And they also built our analysis software for the next part of the data set. Now this slide is simply to show that we know and we recognize, and we are preparing now to deal with what's going to happen when we start to work in very, very deep formations. This new tool, the Insitu tool, like I said, same functionalities, but rated for high temperature and high pressure. That tool will have the capacity to exert 20,000 PSI through these functionalities. And it'll be rated for a collapse pressure of 20 PSI. So that means depending on your mud weight, you could be working at depths of 15, 17, 22,000 feet below surface. 5,000 meters is roughly what we'll be rated to. And temperatures of 330 Fahrenheit, which is 165 Celsius. So anyway, the point of this slide is to show people that we are preparing to handle these effects based on those failure mechanisms, because they will change. There will be an instance where the failure type transitions from shear or tensile to absolute grain collapse, and we will have to account for that. So that's some of the fun stuff we deal with on a day-to-day. Now the intelligent packer. I call it an intelligent packer because when I tell people what its real name is, they immediately think of a pressure gauge. This tool is a pressure meter. It's a civil engineering instrument, first derived in 1955, been in use for 65 years around the world on civil engineering projects, including 84-story skyscrapers in downtown Seattle, hydroelectric dams, tunnels, nuclear waste disposal sites, you name it. Civil engineers have been using pressure meters on critical applications for decades. And we've taken that concept, we've adapted it to fit into a downhole tool. Ours is the biggest on the planet, and ours is capable of exerting 4 times as much pressure as the next toughest pressure meter in the world. That's our intelligent packer for the deep tool. So We changed that name from pressure meter to intelligent packer. It is an appropriate name for the patch, but that is what it is. This is the data set, and this is what kind of information comes out of that tool. And as you can see, this is a huge list. It's absolutely huge, incredibly powerful. These parameters on the top here, there's 6 of them. Those will come out of every physical test. These additional, I think it's 12 parameters, can come out of our modeling. And again, like I said, this software was built by the University of Cambridge solely for our use. And this is part of that software package. But depending on the model that you're applying your data to, depending on the test that you've run, the type of rock, looking for a drained condition, undrained condition, whatever the case is, you would get roughly half of these data points through the specific model. So these blue dots show you the raw data from the intelligent packer. And you can see these little legs, those tails, those are the unload, reload loops as we relax the tool and watch the rock rebound, essentially. Cavity expansion theory is what's happening in the background. And like I said, this has all been kicked around and perfected and beat up by many, many geomechanical experts, civil engineering, geotechnical experts since 1955. We do know that as we go deeper, we're going to be looking at more and more elliptical boreholes where hoop stress is becoming a problem. And we won't be seeing a perfectly gauged hole, not by any means. So we know that we will have to throw out Kirsch's equations and start looking at more numerical modeling approaches. This is an example of deriving moduli from the instrument. Pretty straightforward. And then the final functionality, also straightforward, is the defit or mini frac. Inflate a couple packers, isolate whatever's above from whatever's below, inject your water between the packers, induce fracturing. Shut down your pumps, let that fluid leak off in a natural cycle called a flowback. No, not a flowback, fall off. And then run the test again. You can reverse your pumps and basically put the well on vacuum for a flowback cycle versus the natural fall off, just to accelerate the test and acquire things like permeability and minimum in situ stress. Now getting to applications. I like the one on the bottom because this is the real deal, guys. Anytime you're working above or below or through a layer of rock, and you want to understand those rock strength properties and the stresses that are acting upon them and dictating their behavior, this is the instrument that will physically, directly measure with mechanical means a static property. You can run logging tools and see dynamic properties, absolutely. You can take core samples, hope you get good core recovery, send it all to a lab, run a mini frac separately, absolutely. Or you can look at the data in situ and in real time and use that to complement these other tools. We don't claim to be a silver bullet. We know that it's not a magic wand. There's going to be some pretty tough questions to answer here. But we are a supplement and we're the only technology that can do this. There's tools that run just the defit, sure. There's tools that'll get you a sidewall core, sure. We're not interested in that process. We're interested in seeing the in situ response and measuring the stress conditions as well and seeing it in real time. At the top of the list, and when it comes to oil and gas, even though the patches. Someone's got their.
I think the time is anyway.
Oh, running out of time? Okay.
Here with the. Okay.
The last big point on this slide is to use this data to calibrate all the mechanical earth models that are coming out of things like PASON data and different logging tools. Bit response, looking at the acoustic emissions that are coming from drilling through a specific zone. All of these companies, I'm talking about 10 different companies that provide these mechanical earth models, like Halliburton, Schlumberger, Baker Hughes, Drill to Frac, Frac Pro, Carbo, ResFrac, whatever. They've all told me almost to a man, we need this tool so that we can calibrate our models because they've proven to themselves that their data is sometimes out by 100% because it's not based on a physical measurement. So anyway, we have partnerships with a lot of those companies to work together. Like I said, we're not trying to compete with people. This is the only instrument that does this type of work. And we want to help calibrate those models, and then using existing data and working through something that's going to be very quick is what an operator can tie into and solve their problems. As far as impacts, if we can help identify rock properties along a lateral, because this tool will run on a lateral, and the stress conditions acting upon those properties, you can design a more efficient frac. You can use less water. Right now, we saw on Patrick's slide there how many swimming pools, Olympic pools of water are going into these fracs. And it's been proven many times over the past 5-6 years that 30% of those stages contribute to production, contribute meaningful production. So what does that mean? It means that the other 70% is a waste. And I know that the frackers want to just talk about stimulated rock volume, and that's great. I ain't the one, and my clients are not buying that story anymore. So saving water on a more efficient frac, and that's just one application. You know, there's a lot of ways to apply this information. So anyway, that is that, and I will give the podium back to you. Thank you, Susan.
You're welcome. I just have one quick question, and then we've got some questions for, I think we've got one for Peter, and then I have one for Patrick, and I think, but one quick question is, so how you're going to be testing it in Saudi this fall?
Yeah, so essentially we do have a local operator in Alberta that has 3 test wells for us, but because of COVID, all of their plans have been pushed to the winter.
So this is brand new. It hasn't. This is a brand new technology, and it hasn't actually deployed. Right? Yeah.
Correct. We do have that shallow prototype, and we can go run that anytime, but
Okay.
very limited pressure and temperature wise. So that deep tool is where we're at.
So it's from beginning, from idea scratched on the back of a napkin to now, it was 7 years.
Yeah.
Wow, that's
long road.
yeah, that's admirable. Okay, well, let me go. Okay, so let's ask Peter. Peter, well, there was a question, I think it was for you, about what kind of software you talked about cloud-based software, and you talked about professional software, G&G software that's cloud-based now. Are there a couple of programs that you would recommend?
Well, I can tell you that 3 leading, or what's the right way to describe them? 3 software programs I can think of that are native cloud, native browser-based applications that are making an impact and are kind of well known, and I can divide them up by discipline and by drilling phase. So for drilling, cloud-based drilling software that is aimed at the drilling engineers, for drilling engineering workflows, a really popular package is called Corva, and they're doing really well with that cloud software package. For completion workflows, for the completion engineers and capturing your frac and real-time frac information and analyzing, a really popular native web app is it's called Well Data Labs, which a lot of people I'm sure have heard of. And then, of course, for geoscientists doing drilling workflows, there's ZoneView, which is our software, and that's a third example, I think, of of this new category of GG&E application that runs natively in the cloud, is available strictly through a browser, and sort of represents a new wave, or cloud software on this new side of the paradigm shift, going from PC software to cloud software.
So I have just another quick question, and it kind of ties back to Cory as well, and also Patrick. So Patrick has got a very young, fresh, new idea that's definitely based on paradigm shifts. And I was just wondering, in a software development company, what are some of the challenges, and how long does it usually take to go from the idea to a product that you're selling?
Yeah, well, if you're doing pure product creation, not recycling somebody else's product, but making a brand new software product, or for that matter, a hardware product. It takes a while. So we've been, I heard, in Cory's comments, they've been at it for 7 years and just getting to, commercial application. And that's about how long we've been working on our, on the ZoneView software system. So R&D, it's really hard. I think this is one of the reasons that this kind of innovation doesn't tend to come out of larger organizations. For something, it's too risky. You can't really justify it from a risk perspective, and put it in a spreadsheet. You just have to have a vision and a belief in your vision, and the willingness to pivot and learn as you go, and you just go do battle with ideas, with the market, and you work on your product and you perfect it and you try to get a hearing with it. So I've heard that story. I just heard it again from Cory. So that's why, in our society, we're fortunate, certainly easy for me to say, but I think we're really fortunate that our economy, our society supports the entrepreneur who's willing to take that kind of a risk and go on that long of a journey to try to innovate and create things new, truly new, that take advantage of these paradigm shift opportunities. So,
to put it in perspective, from my viewpoint, and thank you for that, Peter. When I first quit my job and took the leap of faith, sometimes that leap off the side of the ship, that's your only mode of transportation. Mm-hmm. And a lot of people don't get that. And a lot of people don't understand that there will be a lot of times on the road as an entrepreneur when that faith is all you have. And you have to resolve to suffer. That's what I tell a lot of people. You have to resolve to suffer right now. And it might take you, like it's been 7 years. In 2013, mid-2013, I left my desk job, office job, been there for 7 years almost. And it's very comfortable. And put together my business plan, put together my patent application, went and raised money. In 2013 in Calgary, no problem. It took about 3 meetings. The first couple happened at a bar. Next one happened in a boardroom. Boom, we had our seed money. The next couple of years were spent doing development. A lot of it was done overseas. And again, that was a massive mistake. But that's what we did. 2016, went out and tested, had an electrical problem. There wasn't really an invoice. The company was broke. We were essentially broke, almost bankrupt for 2 years. I got paid 3 times in 22 months. Mm-hmm. And I refused to give up because you get the feedback so consistently from all of these operators that, oh my goodness, wow, we can't believe it. That you kind of, it fills your cup, and it keeps the sail full of wind, and it gets you through to the next opportunity. And I started to raise money again in 2017. Things were awful in Alberta. The first time I described it took about 3 meetings. The next time it took 55.
Yeah.
And that is with private equity individuals, firms, operators, service companies. It was brutal. And we raised very little, but we raised enough to continue down the road. And now we generate revenue through consulting, and we're building a demo tool for another company. And we landed this R&D agreement with Saudi Aramco, and one of the biggest service companies in the world is now putting together a contract with us to run this tool for us. Just fantastic, but very, very difficult. And then COVID hit. We had hundreds of thousands of dollars of investment that were about to hit our bank account so we could finish fabrication on time, walk away with COVID and the fall in oil prices. Totally understandable. So that kind of stuff, it hits you all the time, and you got to roll with it.
I would say, and I would compare it to, I think, G&G professionals, GG&E professionals have to take risk all the time. It's risky to drill an oil and gas well. It's risky, to put your reputation on the line and come up with an interpretation of what's going on the subsurface and then stand behind that to management and that kind of thing. I guess the difference is that the entrepreneur is willing to risk their own livelihood. They're willing to basically give up whatever financial security they might have had, and in pursuit of their idea, they believe in it so much that They're willing to put their savings on their line. Hopefully they have a supportive spouse if they have a spouse, and then you just have to have this aptitude for dealing with risk and being able to wake up at the middle of the night at 2 a.m. and get through it and get back to sleep. And so it makes it tough at times, and but it's also very rewarding because you're getting to invent your own job and invent your own sort of path that you're on. So it can be really, I hate to use the word addictive. It's not addictive, but it's a form of reward that once you experience it, so this is why am I in company number 4 right now? And then one response that I give to people, well, why do entrepreneurs do it? And then why do they do it again? And then the answer is, well, why do geese fly south in winter?
Yeah. You're chasing that fix.
Yeah. And you're also, your DNA, it's in your DNA. It's what you do. It's like that Geico commercial. That's what you do.
So Peter, in the case of, so Cory mentioned doing consulting to kind of keep, I guess, related subject kind of consulting to generate some cash flow. Has your company done that?
No, we have stuck, and I'm familiar with that is a valid path. And another path is to acquire a product that's already profitable and then sort of transform it. So, and I've done that in the past, but this one is a pure product play, kind of like a Silicon Valley startup, or you make your product and that's all we do. At UBterra, our core competency is cloud software development as applied to, drilling, visualization, and geosteering. And that's we're standing or falling on that. And
that's interesting. Now, you mentioned earlier that the business model that you've been renovating or revitalizing mature fields is broken. How did it break? And what's broken about it?
Well, I think the reality is that the capital that we were able to raise back 2016, 17 is a very different environment today, just because just the perception. So I think having heard some of SP comments and this ESG, whether we believe it or not, I think that consider how we look at some of our assets and repurpose it. It might also be useful to change the perception that we are looking at transition and we're not just going to be doing the same thing over and over again. Mm-hmm. Now, is it hype or is it going to work? That's why I think a quantitative tool like portfolio approach is one, maybe there are others, is a way to look at what would be the expected outcome. I think over many projects, we've seen if you do your well economic using an average production, which often gives you a more rosy picture, the average is not P50. So what happened is your P50, it could be 20%, 30% different than the mean. And so right off the bat, you set yourself up, let's say on the in the scenario where we raise capital, we say here's the expected return. So people have certain expectations and you already have a 20% deficit from the get-go. So that's the kind of thing I think granularity, use the data and really look at them and set realistic expectation. I think that would help. But it's going to something we have to earn. It's not something we can keep presenting and people will just buy. And so we'll prove it with the drill bit or prove it with a project with the energy storage system and repurpose it. That might change. That might change the whole perception.
It makes a lot of sense, to basically do a proof of concept and show it.
Well, one of the things that I understand the difficulty is proof of concept. So if you're something too big, too capital intensive, nobody's going to touch it today. So that's why when I start looking at this energy storage system, it's talking about water. We already use water for fracking. So there might be some opportunity to look at that. I think Peter talked about the word serendipity. I mean, this is not just serendipity, but it's purposeful reconfiguration, what we do and try out with some of these small scale projects.
Well, that's great. We have a few more questions. Kind of running out of time, but let's go ahead and we started about 5 minutes late due to technical issues. So why don't we just go ahead and ask a few more? They're really good ones. Cory, Robert Gales asks, I'm interested in anticipated time to get tests in deeper and low porosity rocks.
Yeah, so I was just typing out a response here, but this is easier to just say it. That shear head takes about 7 minutes to run per test. The Intelligent Packer takes anywhere from 30 to 45 minutes to run. And then the mini frac, depending on that rock, you know, at 15% porosity would be a dream. You're looking anywhere from 4 hours plus. So you wouldn't run as many mini frac tests, but basically what we tell our clients is to account for 24 hours on that rig, which isn't a small proposition. But you can test 16 zones, 16 individual points within that lateral, and then test 4 or 5 spots in the vertical as well. So depending on the makeup of which actual components you want to run where, we can run every functionality once in about 5 hours. But the most information is coming out of the Intelligent Packer, and that's 30 to 45 minutes, and then the shear head as well, which is only 7 minutes. And as far as differential pressure, everybody tells me we're kicking butt on Baker Hughes and these other fellows. And I've spoken to all of them. They all know what these numbers are, but our differential pressure rating on our Packers is about 9,000 PSI. That's differential. But I just want to share something really quickly. So a couple of folks had mentioned great story, and I really appreciate that. It's really wonderful to get that feedback. But I want to show one picture that kind of adds a little bit more to that, but I need you to make me the presenter again, Susan.
You should still be, but let me make sure. You're still a co-host.
Okay. It's just, oh, I was pressing the wrong button. Okay. So look at this picture here, folks. Oh, where do we go? Let's go share screen. Still didn't work, but this time it should. Huh. I don't know where this has gone. I can see. Oh. Can anybody see my screen by chance?
No, you might have to close some of your windows, some of the windows.
Can you see that?
Yes. Ooh, yeah.
You picture of me laying there dead in a coma?
Wow.
This is what can happen. And this isn't a business thing, but I came back from this. I had a 30% chance of survival.
Wow.
I said that this tool was being built in the UK originally, overseas, and I was flying back and forth to the UK several times a year to work with that team. On one of those trips, you're sitting in economy, you're bootstrapping the hell out of everything. It sucks. You're staying in these bed and breakfasts. They serve you beans and tomatoes with breakfast. I caught something on the plane.
Yeah.
Could have been an unknown form of coronavirus for all I know. COVID, pre-COVID. This is 2015. I got home. I didn't feel real great. Not a big deal. Went back to work. A couple of weeks later, it just got worse and worse. And the weekend before this happened, I slept for 4 hours, and we had a newborn. I've got 4 kids. And I slept for 4 hours when this happened that weekend. But I went to work Monday. I had a couple meetings. I went and played hockey. I went home at 1 p.m, fell asleep in my clothes on my bed. I woke up on Friday. I went to bed. I went home and fell asleep Monday afternoon. I woke up on Friday.
Wow.
I went to a self-induced coma because that night I had a seizure.
Wow.
Which created this viral, it was caused by viral encephalitis, which is when your brain swells due to a virus. I had some kind of infection in my blood. My brain swelled. I had this seizure. My body said, okay, he's hit the breaker button, hit the breaker switch. You're going into a coma or you're going to die. I woke up with no memory. I couldn't walk. I couldn't talk, and had a 30% chance of survival. But here I am, able to play hockey, able to play with my kids, running my business. We've gone from 1 person to 2 to 4 to 8 people in the past 3 years, more like 2.5 years. We've increased our revenue and cash flow by 12, 16, and 10 times over the past 3 years. And we're about to not finish building, but we're well on the way to building this new instrument. So this is the kind of crap that also happens. This is the real life. This isn't the glamorous side of business. People think, oh, you're traveling and you get to go to hotels. No, it's not fun. This is what can happen to you. And this was because I was pushing myself too hard, and I wasn't taking time for myself, and I was ultra stressed, and life happens.
Well,
So-
let me chime in on that, Cory. So when your company makes it, and has, hundreds of employees, and then you get written up, on the front page of the Oil and Gas Journal and so on and so forth, everybody's going to say, wow, an overnight success. And we'll just call that a 20-year overnight success.
Yeah.
And that, in entrepreneurial circles, that's a thing, the 20-year overnight success. It's an inside joke.
Yeah, exactly. Yeah. So it's not all sunshine and moonbeams, that's for sure. But, very grateful to be alive. Every day above ground's a good day. When I can roll out of bed and put my feet on the floor, I'm grateful. Get to meet wonderful people like you all, talk about our technology and make it happen, right? And it's really the people that make it worthwhile. It's nice to pull off interesting technological feats like building custom valves. We had to build our own design and build our own custom valve to handle 20,000 PSI. We've had to develop custom elastomers to handle the temperatures and pressures we're working at with the intelligent packer, because at 20,000 PSI and 330 Fahrenheit, rubber will act like a liquid. So we've had to do all kinds of crazy things that you cannot go down to Princess Auto and buy. And this is the same type of stuff that, the Halliburtons and Baker Hughes and Schlumbergers of the world handle, but we're definitely not those guys. So it's been very interesting. But anyway.
Not to make light of it at all, and what an amazing thing you went through there, and to come back from that. There's all kinds of hazards the entrepreneur faces. One of my examples was I was up in Calgary, and I'm from Denver, and I was with a bunch of people, Calgary oil and gas people, at a lunch, and I started talking about how well the Denver hockey team was doing. And
just about got lynched.
Yeah, I just about got lynched. It was a close call.
When was that? Right after Colorado smoked us in the playoffs last year?
No, this was a few years before that, but still.
Okay.
That's
You
great.
definitely would have been lynched. That had been last year.
Well, this is interesting. I really appreciate your sharing the experiences, and I think there's no better way than to finish on that. And I'll share the questions and also the chat with the panelists so they can get back with the individuals, and also let me know if you want to share your contact information when I send out the email with the link to the recording. And I just want to thank everyone. I want to thank you, Peter, and you, Patrick, and Cory, and also thank you, Larry. And I also want to recognize a few people in our audience. Julie Lemaster, who's been doing, is our director of publicity. And we also want to thank Mark Hemzat, who's been doing a lot of work with recruiting people for UPitch. And I want to thank Hani El Shahawi, who's on the UPitch advisory board as well, and participated in UPitch last week. And also want to recognize Susan Howes, who's been doing a lot with SPE side of members in transition. And let's see, who else do I see that I like to recognize? Well, I see so many people. Sunil Garg is also on our you pitch, and he presented last week as well. So, and Richard Hsu is on the Tulsa Geological Society. Anyway, going on and on. Jim Tucker, leadership of APG. But anyway, so as we usually do, I'd like you to thank you, and also Larry, you have a few final words.
I would just commend you on your coordinating and organizing and taking control of these programs. And the presentations, as usual, were excellent tonight. Very, very interesting and very
Thank you.
very impactful story from Cory. Glad he's still around.
Thank you.
Well, thank you very much. And everyone, look for a couple of days an email from you that will have a link to the recording and also a link to sign up for the next one. Next week is week 14. We're going to do 20 of these. And they will all be archived, and I'm going to create some frameworks of learnings about them so that they can be used in the future. So anyway, thank you everyone, and have a nice evening. Really appreciate all your participation.
Bye.
Good.
Thank you.
Thank you. Thank you, Susan.
Thanks, everybody.
Bye.
Bye-bye.